You're watching the 3.9 lesson video on graphing linear inequalities, day 1. So the cool part about inequalities is if you know how to graph lines, linear inequalities are very similar. You're just kicking it up a little bit because we have some other things to worry about with linear inequalities. Mainly, we have to worry about whether a line is solid or dashed. Okay, you can see it from some of these pictures right here. And you also need to figure out how we're going to shade. All right, well, let's talk about what all that stuff even means. So look at the differences, okay? If you look at all of the inequalities down here, they look super similar to one another, right? Like all of them are 3x or 3 halves x plus 2 on the right-hand side. But there are some changes and there are some differences. As you can see, the line is placed in the same spot on every single graph, but there's some slight changes. Some of the lines are solid and some of them are dashed. Some of the graphs are shaded above and some are shaded below that line, so under it or above it. Okay, so here's a nice little summary for us up top. If we have a greater than or equal to or less than or equal to, mainly if it can equal, it's going to be a solid line. If it's not equal to, the line will be dashed. So it's basically saying that that line doesn't really exist there. The points on that line are not really solutions because they never will equal that function or that y value. But we use it kind of as like a bound to be like, don't go past this. Okay, this is where all the points should be if they were on there. Then the shading is telling us that the points in that area are all solutions. So if y is always bigger than, we're going to shade above. And if y is less than, we are going to shade below. Okay, so keep that in mind as you're looking at a lot of these examples down below. All right, example number 1, let's dive right in. We are going to graph the inequality y is greater than half of x plus 3. Well, I have a strong feeling that all of you already know how to graph this line. Okay, let's figure out what we need. We need the y-intercept, which is 0, 3. Okay, right, if this were an equal sign, we would have no problem graphing it. So we're going to treat it the same way. It's in y equals mx plus b form. Our b, that's our y-intercept, and our slope is 1/2, which means we go up 1 to the right 2, right? This is our m. That's our b. Now, what we do have to pay attention to with an inequality is this sign. Now, because that sign is greater than, we are going to shade our line above. But because it is not equal to, we are going to have a dashed line. But we're still going to seal. We're going to graph it we're going to plot the points just like we would with a normal equation. So we're going to go up 0, 3. We're going to go up 1 to the right 2, right? Yep, up 1 to the right 2, 1 to the right 2. We're going to cover that graph. We're going to go down 1 to the left 2, again, to cover the whole graph. Let's just be thorough. Let's make it adorable, okay? All right, now this is where you want to be careful because we are going to dash this line. So we're going to do straight, extend, but, oh, why didn't that work? Hang on, let's see. We're going to dash it. This is not letting me dash. I don't know what's happening here. Hang on, let me try something different. Let me try this. Okay, my straight edge, I think, is getting cranky right now. Okay, I'm going to use a different straight edge. Now will it let me? Yes. All right, I'm going to dash my line. Do you see how I'm dashing it? So straight, extend that dashed line, arrows, and we're going to label it y is greater than half of x plus 3. We dashed it. Now let's shade above. Shade above. Notice how my shading isn't like coloring in every little box. Like, please don't do that. Do it almost like a perpendicular line, just like I've done here. Now we are done. But we can always use our technology to verify. So let's head over to our calculator. New graph. Well, here we have function notation. We're dealing with an inequality. Let's get rid of that equal sign by pressing delete. And look at all these nice, cute options. Look at, we have some to pick from. I mean, we don't have to. We can use our calculator to get and type everything in, but I'm gonna cheat right now. I'm gonna use this for y is greater than half. Oops, what did I do here? Control divide, so half of x plus 3. And check it out. Now, one thing that I don't like about the graphing calculator is that it's really hard to see if the line is solid or dashed. But here's a little trick. Wiggle your mouse pad, which is right here, and hover over the line, and bam. Do you see how nice and easy it is to see that that is dashed? Not easy, easier. Not as easy, easier. Okay? Now, talking about these points, like why do we shade? Well, any point in this shaded area is a solution to this inequality. So if I put in the point 2, 1, 2, 3, 4, 5, 6, the point 2, 6 algebraically and tried to solve it, well, I put in 6 for my y, so 6 is greater than half of 2 plus 3. Is 6 bigger than half of 2 is 1 plus 3? Is 6 bigger than 4? Yes. So any one of those points that we put into that inequality would be true. Any point that was not in the shaded area would be false. Okay, let's graph number 2. Number 2, we got to get the slope and y-intercept. I'm loving the fact that it's in y mx plus b form. So 0, -5. My slope is 3, so I'm going to write that as 3 over 1, up 3 to the right 1. Then pay attention to the inequality symbol. This is a less than or equal to. Less than means that we are going to shade below, and equal to means we will have a solid line. All right, let's graph it. So 0, -5, 1, 2, 3, 4, 5, and then up 3 to the right 1. We could also go down 3 to the left 1, but let's just follow this whole pattern. Cover the graph. You know the drill. Make it look nice. Straight. Extend. So we are going to use a solid line now because it could equal. Arrows. We're going to label it y is less than or equal to 3x minus 5, and we need to shade below, so underneath, which is all of this space down here. Notice how I'm shading again. I'm not coloring in every single box. If I wanted to, I could check using my calculator, but I already showed you how to do that on example number 1. So I would encourage you to do that when you are working on your practice questions.